Hello friends, in this video we are going to see the JEE main previous year questions from the topic redox reactions. First, let us see the 2025 and 2026 questions. Then we will go to the topic wise questions discussion. Let us see the first question which was asked in 2026 January exam. Identify the correct statements. Hydrated salts can be used as primary standard. Primary standard should not undergo any reaction with air. In this question, we are talking about primary standard. First, let me explain what is a primary standard. Primary standard is exceptionally pure, stable, and non-hygroscopic. Non-hygroscopic means the substance should not absorb water, that is moisture, from the air. So the primary standard is exceptionally pure, stable, non-hygroscopic reagent. So this reagent is used to prepare solutions of known concentrations. So to prepare a solution of accurately known concentration, we are using this primary standard. So this primary standard should be pure, stable, and non-hygroscopic. What is the use of this primary standard? Primary standard is used to standardize the other solutions, or you can say standardize the secondary standards. What is meant by standardization? So when you have a solution and you don't know the concentration of the solution, then to find the concentration, to find the unknown concentration of other solution. So to find the unknown concentration of the other solution, we use the primary standard. So the other solutions are usually the secondary standard solutions. So this is the definition of a primary standard. Now let us see the given statements. Hydrated salts can be used as primary standard. The first statement is correct because some hydrated salts, if they are stable, then they can be used as primary standard. So the best example for this is Morse salt, which is ammonium iron 2 sulfate, which is having the formula NH4 twice Fe SO4 twice dot 6H2O. So it is a hydrated salt and it is also used as a primary standard. So the first statement is correct. The second statement is primary standard should not undergo any reaction with air. So the second statement is also correct because already we have mentioned it should be stable. So it should not react with O2 or CO2 or moisture in air. So it should be stable. So the second statement is also correct. Reactions of primary standard with another substance should be instantaneous and stoichiometric. The third statement is also correct because when the primary standard is reacting with the other substance, the reaction should be fast and complete. The reaction should be fast and complete. So this has to be stoichiometric. The reaction has to be stoichiometric to ensure the accurate results. To get the accurate results, we have to see the correct stoichiometry of the reaction. So the reaction of the primary standard with another substance should be stoichiometric. Then the next statement is primary standard should not be soluble in water. This statement is wrong because it should be readily soluble in water. It should be readily soluble in water. So only you can make the solution of the primary standard reagent. Then the next statement, primary standard should have low relative molar mass. This statement is also wrong because it should have high molar mass, high relative molar mass, so that it will be easy to weigh the reagent. Because if the molar mass is very low, then we will get error in weighing the reagent. So to minimize the error, in weighing, the molar mass should be very high. So the correct statements are the first three statements A, B, C. So the correct option is option 3. Next question is 200 cc. Cc is cubic centimeter. So it refers to 200 ml. 200 ml is nothing but 0.2 liters. So 200 cubic centimeter of X into 10 power minus 3 molar potassium dichromate. So concentration and volume is given and potassium dichromate is mentioned. K2Cr2O7 is required to oxidize 750 cc. So what is 750 cc? It is 750 ml. So I will write it here. 750 cc is 750 ml, which is 0.75 liters of 0.6 molar more salt solution in acidic medium. Here X is, so potassium dichromate is oxidizing more salt in more salt. So the formula is ammonium iron 2 sulfate. So in this salt, iron will be present in +2 oxidation state. So oxidation of iron takes place by what? By potassium dichromate. So potassium dichromate is acting as an oxidizing agent. So we will see the reactions. So first, let us see the oxidation reaction. Oxidation half reaction of this more salt, in which iron, which is present in +2 oxidation state, will be converted to +3 oxidation state. So oxidation of iron takes place. So actually what is oxidation? Oxidation is loss of electron. So loss of electron should be written in the product side. How many electrons are lost? So see the change in the oxidation number, +2 to +3. So it is 1 electron. So here the number of electrons involved, N factor, is 1. Now let us see the reduction half reaction. So here potassium dichromate is acting as a oxidizing agent. Oxidizing agent will itself undergoes reduction. So let us see the half reaction. So potassium dichromate K2Cr2O7 we can write as Cr2O7 2 minus. So always in reduction half reaction, that is reduction, gain of electron takes place. Gain of electrons. Gain of electrons should be written in the reactant side. So I have left some space for that. Now this potassium dichromate in acidic medium, it will be converted to Cr3 plus. So here 2 chromium atoms are there. So only I have written 2 Cr3 plus. Now you balance the oxygen atoms. 7 oxygen atoms are there in the reactant side. So to balance the oxygen atoms in the product side also, we are going to introduce water molecules, 7H2O. So in one water molecule, 1 oxygen atom is there. So 7 water molecules are introduced. Now how many hydrogen atoms are there in product side? 7 into 2, 14 hydrogen atoms. But in reactant side, no hydrogen atom is there. So just we have to write 14H plus. As it is already mentioned, it is acidic medium. So 14H plus is written in the reactant side. Now let us see the electrons, number of electrons gained. So first you calculate the oxidation number of chromium in this compound. So for the unknown element, you have to keep it as X. 2 chromium atoms are there. So 2X plus oxidation state of oxygen is -2. How many atoms are there? 7 atoms are there. So that is equal to the charge of the ion, that is -2. So 2X minus 14 equal to -2. 2X equal to 12. So the value of X is 6. So from +6, it has changed to +3. So what is the difference? 3 is the difference. But how many number of chromium atoms are there? 2 chromium atoms are there. So 3 into 2, 6 electrons. So both the chromium atoms together gain 6 electrons for the reduction. So this is the half reaction, reduction half reaction. So let me erase this. Now how many electrons are involved here? 6 electrons are involved. So the N factor is equal to 6. Now we are going to use the law of equivalence. So we will use the law of equivalence. So what is law of equivalence? Equivalence of potassium dichromate is equal to equivalence of Morse salt. So how will you find the equivalence? The formula of equivalence is equal to number of moles into N factor. So for the reduction half reaction, that is for potassium dichromate, N factor is 6. So let us keep this as N1. N1 is equal to 6. And for the oxidation, The n factor is 1. So let us keep this as n2. n2 is equal to 1. Now in this formula, number of moles is also mentioned. How can we find the number of moles? Because in question, number of moles is not given directly. Volume and concentration is given in molarity. So we can find the number of moles from that, because we know molarity is equal to number of moles by volume. So number of moles is equal to molarity multiplied by volume. So from this rearrangement, we can find the number of moles. So number of moles is equal to molarity into volume, and this is multiplied by the n factor. So let us keep the volume of potassium dichromate as V1 and the molarity of potassium dichromate as M1. Volume of more salt is V2, molarity of more salt is M2. So let me write that. Equivalence of K2Cr2O7 is M1, V1, N1. Here this N1 refers to the n factor. So this is equal to M2, V2, N2. So just we have to substitute the values. So what is the value of M1? So let me continue in the next page. M1, V1, N1 is equal to M2, V2, N2. What is the value of M1? X into 10 power minus 3. So X into 10 power minus 3. What is the value of V1? So 200 cc is 0.2 liters. So it is 0.2 into N1 value we have written here. It is 6. So into 6 is equal to M2 value is given as 0.6 and V2 is 750 cc. So that is equal to 0.75 liters. So it is 0.6, 0.75, and what is the value of N2? N2 value is 1, because in oxidation reaction the number of electrons involved is 1. So it is 1. So when you solve this equation, you will get the value of X. So let me solve that. X into 10 power minus 3, 0.2 into 6 is 1.2. So that is equal to 0.6 into 0.75. So X into 10 power minus 3 is equal to, let us take this 1.2 to the right hand side. So 0.6 into 0.75 divided by 1.2. So X into 10 power minus 3 is equal to, multiply 10 in 0.6 and 1.2. So you will get 6 by 12 into, so here you multiply by 100 in numerator and denominator. So you will get 75 by 100. So X into 10 power minus 3 is equal to, when you solve this, when you cancel this, you will get 2. 6 by 12 is 2. 75 divided by 2 is 37.5. So 37.5 divided by 100. Take this 10 power minus 3 to the other side. So X is equal to 37.5 by 100 is 0.375 divided by taking this 10 power minus 3 to the denominator. So when it comes to the numerator, it will become 0.375 into 1000, 10 power 3, which is nothing but 1000. So you will get the answer as 375. So the value of X is, so the final value here, X value is 375. So I hope you understood this question. You have to see the reduction half reaction and oxidation half reaction, then find the number of electrons involved in this reaction, then use the law of equivalence, M1 V1 N1 is equal to M2 V2 N2. Because in question volume and molarity is given, in equivalence formula you want the number of moles. From molarity and volume you can find the number of moles. So I hope you understood this question. Next question is, X and Y are the number of electrons involved respectively during the oxidation of I minus to I2 and the S2 minus to S by acidified K2Cr2O7. The value of X plus Y is, here also acidified K2Cr2O7 is used. So it is acting as a oxidizing agent. An oxidizing agent will itself undergo reduction. So here it is acting as oxidizing agent to oxidize I minus to I2 and S2 minus to S. So let us see the reactions separately. First, oxidation half reaction, I minus is converted to I2. What is oxidation? Oxidation is loss of electron. So how to see the number of electrons lost? First, balance this equation. In left side only one iodine atom is there, right side 2 atoms are there. So 2I minus gives I2. Now see the charge, see the oxidation number. Oxidation number of I minus, charge is -1. So the oxidation state is -1. Oxidation state of I2 is the elemental form, so it is 0. So what is the difference? The difference is 1. So 1 electron is lost. But how many atoms are there? 2 atoms are there. So for both the iodine atoms, 1 electron into 2, so 2 electrons are lost in total. So always remember that oxidation is loss of electron, so you have to write that in the product side. So it is 2 electron. Now let us see the oxidation of S2 minus. S2 minus is converted to sulfur. So this is also oxidation, as it is already mentioned in question. Now see the charge. From 2 minus, it is converted to 0. So what is the difference? 2 electrons. So as it is loss of electron, you have to write that here. So totally, iodine loses 2 electrons. Iodide ion loses 2 electrons, and S2 minus sulfide ion also loses 2 electrons. Now let us see the reduction half reaction, because potassium dichromate is used as an oxidizing agent which itself undergoes what? Reduction. So let us see the reduction half reaction. So in the reduction half reaction, we can write the K2Cr2O7 as Cr2O7 2 minus. We already saw this in the previous sum itself. Reduction, what is reduction? Reduction is gain of electrons. Gain of electrons will be written in the reactant side. So you leave some space. So in acidic medium, Cr2O7 2 minus is always converted to 2Cr3 plus. So already we saw the oxidation number from +6, it is converted to what? +3. So what is the difference? The difference is 3 electrons. 3 electrons are gained. But totally how many chromium atoms are involved? 2 chromium atoms are involved. So into 2. So that is equal to 6 electrons. So totally 6 electrons are involved here. Why I have written 2 in the product side for Cr3 plus? Because in reactant side we are having Cr2O7 2 minus. So to balance, I have written the 2. So how many electrons are gained? 6 electrons are gained. Now what is the complete reaction? You have to balance the oxygen atoms. 7 oxygen atoms are there. So in product side we are writing 7 water molecule. In water molecule you are having hydrogen. 7 into 2, 14 hydrogen atoms are there. So to balance that, in reactant side you have to write 14H plus. So now the oxidation half reaction and reduction half reaction should be added. But before that, number of electrons lost should be equal to number of electrons gained. So here the number of electrons gained in the reduction half reaction is 6. But if you see the oxidation half reactions for both the equations, the number of electrons lost is only 2. So you have to equate. So for that, you have to increase the number of moles of the reactants. So as a whole, you have to multiply the whole equation by 3, because only when you multiply by 3, 3 into 2, you will get 6 electrons. Then for the second equation also, you have to multiply by 3. Now what will be the half reactions? So see the half reaction. 6I minus gives 3I2 plus 6 electrons. Then the second reaction is 3S2 minus gives 3S plus 6 electrons. Now you have to separately add. So let us keep this as the first equation, this is the second equation, and this one as the third equation. So you have to separately add first equation and the third equation. So add 1 and 3, and then you have to add second equation and the third equation, because these two reactions are happening separately, because in question it is given X and Y are the number of electrons involved respectively. So the reactions are separate. So let us see the adding of the equations. So I have written all the 3 equations. First, let us add 1 and 3. So you add the reactant and the product side separately. Now in the reactant side you are having 6 electrons in the third equation, and in product side you are having 6 electrons in the first equation. So it will get cancelled. So the remaining reactant and product side are Cr2O7 2 minus plus 6I minus plus 14H plus gives 2Cr3 plus 3I2 plus 7H2O. So here how many electrons are getting cancelled? So the number of electrons involved in this reaction is 6. So this is the value of X. So in question it is given. The X and Y are the number of electrons involved. So for the oxidation of I minus to I2, the number of electrons involved X is equal to 6. Now let us add the second equation and the third equation. Here also in reactant side you are having 6 electrons, and in product side of the second equation also you are having 6 electrons. So the remaining is Cr2O7 2 minus plus 3S2 minus plus 14H plus gives 2Cr3 plus 3S plus 7H2O. So here also the number of electrons involved is equal to 6. So the value of Y is also 6. No need to add the equations. Just by equating the number of electrons itself, we can clearly see the number of electrons involved is 6 in all the 3 equations. So the number of electrons involved is equal to 6. So from this itself, we can conclude the value of X and Y is equal to 6. So here they are asking X plus Y. So X plus Y is equal to 6 plus 6, that is equal to 12. So the answer is 12. So I hope you understood this question. Next question is, 1 mole of Cl2 was passed into 2 liters of cold 2m KOH. For chlorine molecule, number of moles is mentioned as 1 mole. For potassium hydroxide KOH, number of moles is not mentioned, but volume and concentration is mentioned. How can we find the number of moles? Number of moles is equal to molarity into volume. So that is equal to, molarity is mentioned as 2. So 2 into volume is 2 liters. So 2 into 2, 4 moles. So the available number of moles of chlorine is 1 mole. Available number of moles of KOH is also we found now 4 moles. After the reaction, the concentrations of Cl minus, ClO minus and OH minus are respectively. Assume volume remains constant. So the volume is mentioned in question as 2 liters. So they are telling us to assume the volume remains constant. Now let us first write the equation. So the reactants are Cl2 and it reacts with KOH. So the products are Cl minus plus ClO minus. This minus indicates that a metal is present near this anion. So that metal is obviously what? It is potassium, because in the reactant side we are having potassium only. So instead of writing Cl minus, we can write KCl, and instead of writing ClO minus, we can write KClO. Now if you see the reactant side, only 1 potassium atom is there, but in product side 2 potassium atoms are there. So to balance that, you have to write in reactant side 2 KOH. Now if you see the reactant side, 2 oxygen atoms are there and 2 hydrogen atoms are there. In product side, only 1 oxygen atom is there. So we can simply balance this by adding water molecule. Now the number of hydrogen atoms is 2 on both the side, and number of oxygen atoms are also 2 on both the side. Now let us see the number of moles available. Available number of moles is nothing but given in the question, that is the available number of moles. So for chlorine, the number of moles available is 1, and for KOH, the number of moles available is 4. Now let us see the coefficient, that is the number of moles according to the stoichiometric equation. So according to the stoichiometric equation, 1 mole of Cl2 reacts with 2 moles of KOH. So the stoichiometric coefficient is 1:2. Now we can find the limiting reagent. You may think why we are finding the limiting reagent, because in question we are talking about the concentration of Cl minus and ClO minus. So for that you need to know the number of moles of KCl and KClO. So the number of moles of product is determined by the limiting reagent only. So we have to find the limiting reagent. So the limiting reagent is found by using the formula available number of moles divided by the stoichiometric coefficient. So let us divide the available number of moles for Cl2. Available number of moles is 1 and the stoichiometric coefficient is also 1. So we are getting the number 1. Then for KOH, available number of moles is 4 and the stoichiometric coefficient is 2. So we are getting 2. Now the one reactant which is having the lowest value is called as the limiting reagent. So the one which is having the lowest value in this formula is called as the limiting reagent. So now from this equation, the limiting reagent is Cl2. So what is the use of the limiting reagent? The limiting reagent only decides the number of moles of the product formed. So for that only we are finding the limiting reagent. Now in question, another one ion is also mentioned. OH minus. What is OH minus? How OH minus came into this equation? It is nothing but the reactant. In reactant, KOH is actually excess because 1 mole of Cl2 reacts only with the 2 moles of KOH. Available is also 1 mole of Cl2, but KOH is actually excess. So the excess of KOH is present in the solution as it is. So you have to find the concentration of the excess KOH. So that is only mentioned as excess of concentration of OH minus. So now let us see the number of moles of the product formed. So again let us write the equation. Cl2 plus 2 KOH gives KCl plus KClO plus H2O. So now we found that the limiting reagent is Cl2. So in question it is given 1 mole of Cl2 is present. So this 1 mole of Cl2 will give how much moles of KCl and KClO. So let us see the equation. So by equation itself, 1 mole of Cl2 is giving 1 mole of KCl and KClO. So available is also 1 mole. So 1 mole of Cl2 is going to give 1 mole of KCl and 1 mole of KClO. Now let us see the remaining KOH. So in question, the available number of moles of KOH is 4 moles. But according to the stoichiometric equation, 1 mole of Cl2 reacts with only 2 moles of KOH. So in the question also, the available number of moles of Cl2 is 1 mole only. So it is going to react only with the 2 moles of KOH. So what is the remaining? The remaining is 2 moles of KOH is in excess. So this is the excess of KOH. Now let us find the concentration. Here in this question, concentration is expressed in molarity. So how to find the molarity of the three substances? Molarity is equal to number of moles divided by volume. So already in question it is mentioned the volume remains constant. So what is the volume already given? 2 liters. So that is the volume you have to use. So the concentration of Cl minus is equal to number of moles. So number of moles is 1. 1 divided by volume. Volume is 2. So it is 0.5 m. Then concentration of ClO minus is equal to number of moles is 1 divided by volume is 2. So that is also 0.5. Then last, concentration of OH minus. So the number of moles is 2. 2 divided by the volume 2. So that is equal to 1. So the concentrations of Cl minus is 0.5 m. ClO minus is also 0.5 m. Then OH minus, that is the excess reactant, is 1 m. So the correct option is option 1, 0.5 m, 0.5 m, 1 m. I hope you understood this question. Next question is 500 ml of 1.2 m Ki solution is mixed with 500 ml of 0.2 m KMnO4 solution in basic medium. In this question also, number of moles is not mentioned. So let us find the number of moles by multiplying the given concentration into volume. So the concentration is 1.2 molar. So 1.2 into the volume is 500 ml. 500 ml should be converted to liters. So it is 0.5 liters. So 1.2 into 0.5 is 0.6 moles. So in this question, 0.6 moles of Ki solution is mixed with 500 ml of 0.2 m. So here the number of moles is equal to molarity into volume 0.2 into again 500 ml. So it is 0.5 liters. So that is equal to 0.1 moles. So this Ki solution is mixed with 0.1 moles of KMnO4 solution, and that too in basic medium. So here what is happening? KMnO4 is a very good oxidizing agent. So that is going to oxidize this Ki. So the iodide ion is oxidized to iodine and it is happening in the basic medium. The liberated iodine was titrated with the standard 0.1 m Na2S2O3 solution in the presence of starch indicator till the blue color disappeared. The volume of Na2S2O3 consumed is dash. So for the volume of Na2S2O3 consumed, you need to know the number of moles of Na2S2O3 because the concentration is already mentioned in question. So how many number of moles of Na2S2O3 is consumed? You have to know that. For knowing that, first you have to know the number of moles of iodine that is formed in the reaction, first reaction. So now let us see the first reaction. So in first reaction, we know KMnO4 is an oxidizing agent and an oxidizing agent itself undergoes what? Reduction. So let us see the reduction half reaction. So MnO4 minus and it is in basic medium. So in question it is mentioned as basic medium. So in basic medium, it is converted to MnO2. So if you compare the oxidation states, in MnO4 minus, the oxidation state of manganese is +7 and in MnO2, the oxidation state of manganese is +4. How will you find the oxidation state? For the unknown element, it is X. X plus, for oxygen, it is -2 and 2 atoms are there. So everything equal to 0. So X minus 4 equal to 0, X is equal to +4. So this is how you have to find the oxidation state. So now, what is the difference in the oxidation state? From +7 to +4, the difference is 3. Reduction is gain of electron. So gain of electrons should be written in the reactant side. So by the gain of 3 electrons, MnO4 minus is converted to MnO2. Now let us balance this equation. 4 oxygen atoms are there in the reactant side. Only 2 oxygen atoms are present in the product side. So write 2H2O to balance the oxygen atoms. Now see the hydrogen atoms. 4 hydrogen atoms are there in the product side. So in reactant side, we have to write 4H plus. So now balance H plus. So MnO4 minus plus 4H plus. But this reaction is happening in basic medium. So when you introduce H plus, then you should also introduce what? OH minus. So the number of H plus you introduce in that same way you have to introduce the number of OH minus also. So 4H plus 4OH minus plus the number of electrons which is already written 3 electrons gives MnO2 plus 2H2O. But here we have written 4OH minus, no? That should be on both the side. On both the side you have to introduce the OH minus. H plus we have written only in the reactant side. Why? Because already 4 hydrogen atoms are there in the product side. OH minus you are going to introduce on both the side. So when you see the reactant side, H plus and OH minus together make water molecule. So this we can write MnO4 minus plus 4H2O plus 3 electrons gives MnO2 plus 2H2O plus 4OH minus. Now in reactant side 4H2O is there and in product side 2H2O is there. We can cancel that and remaining is in reactant side you will be having 2H2O. So this is the reduction half reaction. So let me write the last equation alone. So let us write the last equation alone. MnO4 minus plus 2H2O plus 3 electrons gives MnO2 plus 4OH minus. Let me erase the remaining. Now let us see the oxidation half reaction. Oxidation half reaction. So what is oxidation? Oxidation is loss of electrons. Here Ki, that is I minus, is converted to iodine. First balance this equation. 2I minus, because in product side we are having I2. So introduce 2 in the reactant side. So we know oxidation is loss of electrons. Now we have to find how many electrons are lost. See the charge, oxidation number. So here the oxidation number is -1 and I2 is in the elemental form, so it is 0. So what is the difference? The difference is 1. But how many atoms are involved? 2 atoms are involved. So 1 into 2 which give 2 electrons. So if you see the change in the oxidation number, it tells that 1 electron is lost by 1 iodide ion. Then for 2 iodide ion, it is 2 electrons. So now you have to add the oxidation half reaction and the reduction half reaction. Before that, you have to equate the number of electrons, because in redox reaction, the number of electrons lost should be equal to number of electrons gained. But here it is not same. So multiply the reduction half reaction by 2 and the oxidation half reaction by 3. So here you will get 2MnO4 minus plus 4H2O plus 6 electrons gives Mn2MnO2 plus 8OH minus, and here you will get 6I minus gives 3I2 plus 6 electrons. Now when you add these two equations, you will get, so here you can cancel the number of electrons lost by the number of electrons gained. So here you will get 2MnO4 minus plus 6I minus plus 4H2O gives 2MnO2 plus 3I2 plus 8OH minus. So let us continue in the next page. So this is the overall reaction. Now in this overall reaction, see the coefficient, that is the stoichiometric coefficient of 2MnO4 minus is 2 and I minus is 6. So according to the equation, 2 moles of MnO4 minus reacts with 6 moles of I minus. Now let us compare this with the available number of moles. So the available number of moles in question we have found, already we have found. For Ki it is 0.6 and for KMnO4 it is 0.1. So let us write that. So the available number of moles for MnO4 minus KMnO4 is 0.1 and for I minus it is 0.6. So now we have to find the limiting reagent. So the limiting reagent already we saw. We have to find it by dividing the available number of moles divided by the stoichiometric coefficient. So for KMnO4, that is MnO4 minus, available is 0.1 divided by coefficient is 2. So you will get it as 0.05. Then for Ki, that is I minus, the available is 0.6 by the coefficient 6. So here you will get 0.1. So which is the lower value? KMnO4, that is MnO4 minus, is the limiting reagent because it is having the lower value. So here the limiting reagent is MnO4 minus. So according to the limiting reagent only, the number of moles of iodine formed is decided. So in this question, the available number of moles of MnO4 minus is 0.1. So how many moles of I2 will be formed? Let us compare that with the coefficient. The coefficient of MnO4 minus is 2 and the coefficient of I2 is 3. So let us compare them. So let me erase the remaining. So here we are comparing MnO4 minus and I2. So according to the coefficient, 2 moles of MnO4 minus gives 3 moles of I2. Then 0.1 moles which is available in question, 0.1 moles of MnO4 minus gives how many moles of I2? So just do the cross multiplication. So you will get 0.1 into 3 divided by 2. So when you cancel this, 3 by 2 will give you 1.5. So 1.5 into 0.1 is 0.15 moles. So in this reaction, 0.15 moles of I2 is produced. But what is the question? The liberated iodine, that is liberated 0.15 moles of iodine was titrated with the standard 0.1 m sodium thiosulfate. So what is the volume of sodium thiosulfate? To find the volume, already I told you need to find the number of moles. So for that also, you need to know the reaction equation. So the reaction of iodine I2 with sodium thiosulfate S2O3 2 minus will give again the iodide ion I minus plus S4O6 2 minus. So you have to balance this equation. 2 iodine atoms are there. So in react product side also 2 iodide ion. Then 4 sulfur 6 oxygen atoms are there. So in reactant side just write 2 S2O3 2 minus. Now the equation is balanced. So according to the equation, we are having the coefficient for iodine as 1. So 1 mole of I2 reacts with 2 moles of S2O3 2 minus sodium thiosulfate. Then in this problem we got 0.15 moles of iodine reacts with how many moles of S2O3 2 minus. So just do the cross multiplication. So 0.15 into 2 divided by this number 1. So you will get 0.30 moles of S2O3 2 minus. Now you have to find the volume. So here we are having number of moles And in question, the molarity of sodium thiosulfate is given. We know molarity is equal to number of moles by volume. Then if you rearrange this, volume is equal to number of moles by molarity. So the volume you have to find. So the number of moles is 0.30 divided by molarity is given in question 0.1. So divided by 0.1. So multiply by 10, 3 by 1. So the answer is 3 liters. So finally we got the answer as 3 liters. So I hope you understood this question. Next question is compounds that should not be used as primary standards in titrometric analysis are. First option is given as Na2Cr2O7, that is sodium dichromate. This cannot be used as a primary standard because it is highly hygroscopic. So it absorbs moisture from air. So it is not stable. So sodium dichromate cannot be used. Instead of that, potassium dichromate can be used as a primary standard, but in this question, sodium dichromate is only given, so it cannot be used. Next one is oxalic acid. Oxalic acid can be used as a primary standard because it is pure and stable, and also it is non-hygroscopic. So these are the conditions for a reagent to be primary standard: pure, exceptionally pure, stable, and non-hygroscopic. So the next one is NaOH. Sodium hydroxide also cannot be used as a primary standard because it is also not stable and it reacts with moisture, that is, it is hygroscopic, and it reacts with carbon dioxide, reacts with CO2 present in air. So it is not considered as a primary standard, it is considered as a secondary standard. The next is ferrous sulfate. Ferrous sulfate also cannot be used as a primary standard because in ferrous sulfate, Fe is present in +2 oxidation state. So it is easily oxidized to +3 oxidation state by air. So it is easily oxidized by air. So it means that it is not stable. So only when a reagent is stable, it can be used as a primary standard. Here, ferrous sulfate, that is not stable because it is easily oxidized by air. Next one is sodium tetraborate, that is borax. Borax also can be used as a primary standard because it is pure and not easily decomposed. That is, borax is considered as a stable compound. So out of the given compounds, A, C and D cannot be used as a primary standard. So the correct option is option 4. A, C and D cannot be used as primary standard. I hope you understood this question. Next question is match list 1 with list 2. So in list 1, redox reaction is given, and in list 2, type of redox reaction is given. So the first one is CH4 plus 2O2 gives CO2 plus 2H2O. So this reaction is an example of combination reaction because in this reaction, oxygen is combining with methane to produce different products. Here, oxygen combines with the carbon as well as hydrogen. So this carbon is converted to carbon dioxide. Then hydrogen and oxygen combine to form water. So it is a combination reaction. So the first one, A, the correct match is 2. So for A, it is 2. Next reaction, B reaction. 2NaH gives 2Na plus H2. So it is a decomposition reaction because a single reactant decomposes into simpler substance. So it is a decomposition reaction. So the decomposition reaction is the third option. So for B, it is 3. Then C reaction, V2O5 plus 5Ca gives 2V plus 5CaO. So here calcium is displacing vanadium from its oxide. So vanadium oxide is given in the reactant. So in that oxide, vanadium is being displaced, and here calcium is displacing vanadium from its oxide. So this reaction is definitely displacement reaction. So displacement reaction is the fourth option. So for C, it is 4. Then the last reaction, 2H2O 2H2O2 gives 2H2O plus O2. So it is a well-known reaction. In H2O2, oxygen is present in the intermediate oxidation number. So the oxidation number of oxygen is -1. Then it is converted to -2 in water and 0 in oxygen molecule. So there is both decrease in oxidation number as well as increase in oxidation number. So both decrease and increase represents oxidation and reduction. So that is happening in the same element. Same element undergoes both oxidation and reduction. So this is called as disproportionation reaction. So for the reaction D, the correct option is 1. So now let us write the options. For A it is 2, for B it is 3, for C it is 4, and for D it is 1. So the correct option A2, B3, C4, D1. So let me erase this. So the correct option is option 4. So I hope you understood this question. Next question is the species which does not undergo disproportionation reaction is. So first, what is a disproportionation reaction? So in this reaction, same element undergoes both oxidation and reduction. So for an element to undergo both oxidation and reduction, there is a condition that the element should be present in intermediate oxidation state in the reactant. So only when the element is present in the intermediate oxidation state in reactant, it can undergo both the increase in oxidation state as well as the decrease in oxidation state. And also the element should exhibit at least 3 variable oxidation states. For example, oxygen exhibits -1 oxidation state, 0 oxidation state, -2 oxidation state also. And in some compounds, it also exhibits +2 oxidation state also. So like that, the element should at least exhibit 3 variable oxidation states. Now let us see the given options. So in given option, let us find the oxidation states. ClO3 minus. So we have to find the oxidation state of the metal. So sorry. ClO3 minus, we have to find the oxidation state of chlorine. So X minus, the oxidation state of oxygen is -2. So -2 into 3 atoms are there. So that is equal to the charge -1. So X minus 6 equal to -1. So the value of X is +5. So here the value of X is +5. Now let us see the next option. ClO minus X, -2 equal to -1. X is equal to -1 plus 2. So that will give +1 oxidation state. Then ClO2 minus X, -2 into 2 equal to -1. X -4 equal to -1. So when you take the -4 to the other side, X is equal to -1 plus 4. So that will give +3. Then the last one, ClO4 minus X minus 2 into 4 equal to -1. X minus 8 equal to -1, X is equal to +7. So here the oxidation state is +7, and in the third option the oxidation state is +3. So chlorine will have a maximum highest oxidation state of +7 and the lowest oxidation state is -1. But if you see the fourth option, already it is present in the highest oxidation state. Here chlorine is present in the highest oxidation state. So it is not the intermediate oxidation state. Here the condition should be the intermediate oxidation state. The next question is, given below are 2 statements. First statement, in the oxalic acid versus KMnO4 in the presence of dilute H2SO4 titration, the solution needs to be heated initially to 60 degrees Celsius. But no heating is required in ferrous ammonium sulfate versus KMnO4 titration in the presence of dilute H2SO4. So here we are talking about two titrations. The first one is oxalic acid versus KMnO4. So in this titration, heating is required. So that is what given in the question. So in the statement, so this is actually correct because in this oxalic acid versus KMnO4 titration, so this oxalic acid will be taken in the conical flask and this KMnO4 will be taken in the burette. So in this titration, the rate of the reaction, that is initially the rate of the reaction is slow. Therefore, to enhance the rate of reaction, heating is required. And so initially the rate of the reaction is low. So initial stage alone heating is required. Then what happens after that? So during the reaction, Mn2 plus ions are formed which will act as a catalyst. So during the reaction, KMnO4 will be converted to Mn2 plus ions. So this is happening in presence of dilute H2SO4, no? So it is actually MnSO4 in which Mn2 plus is present. So this will be formed during the reaction. So as the reaction proceeds, this Mn2 plus ions will itself act as a catalyst. So during the initial rate alone, heating is required. Now the second titration is FAS versus KMnO4. So the second titration is FAS, ferrous ammonium sulfate versus KMnO4. In this titration, heating is not required. Why? Because the reaction rate is already very high even at room temperature. So even at room temperature, the reaction rate is high. The reaction immediately starts. So no need to heat in this FAS versus KMnO4 titration. And also if we heat this solution, what will happen? In ferrous ammonium sulfate, Fe2 plus ions are present. When you heat this ferrous ammonium sulfate solution, the Fe2 plus ions present in that solution will react with the oxygen in air and it will be converted to Fe3 plus. So here oxidation takes place. But this oxidation is not by the oxidizing agent KMnO4. It is happening due to O2. So this is called as premature oxidation. So here premature oxidation occurs. So to avoid this premature oxidation, heating is not done in this experiment, FAS versus KMnO4. So the first statement is correct. Now let us see the second statement. In oxalic acid versus KMnO4 titration, the initial formation of MnSO4 takes place at a high temperature, which then acts as catalyst for the further reaction. So this is correct. As I already mentioned here, MnSO4, that is Mn2 plus formed, will act as a catalyst in this reaction. Then in this case of FAS versus KMnO4, heating oxidizes Fe2 plus into Fe3 plus by oxygen of air and error may be introduced in the experiment. So this is also correct because already I told premature oxidation occurs if we heat this FAS solution. So the statement 2 is also correct. So let us see the options. In light of the above statements, choose the correct answer from the options given below. So here the statement 1 and 2 are true or false is asked. So already we saw both the statements are correct only. So both statement 1 and 2 are true. So this is the answer. Next question is 0.1 m solution of Ki reacts with excess of H2SO4 and KiO3 solutions according to equation. So an equation is given in the ionic form. Now identify the correct statements. 200 ml of Ki solution reacts with 0.04 mole of KiO3 and 3 more options are given. So choose the correct answer from the options given below. So out of the 4 options, you have to find which option is correct. So first, let us see the option A. in option A, they are telling 200 ml of Ki solution reacts with 0.04 moles. So here we are talking about moles. So you have to convert this volume into number of moles. So we know the formula, number of moles equal to molarity into volume. So the molarity of Ki solution is already mentioned, 0.1 into volume is 200 ml. So that is 0.2 liters. So the number of moles is 0.02 moles. According to the equation given in question, 5 moles of iodide ions reacts with 1 mole of IO3 minus. So write that. So 5 iodide ions reacts with 1 mole of IO3 minus ions. Therefore, in question it is given 0.02. So 200 ml of K is 0.02 moles of I minus. It reacts with how many moles of IO3 minus? So the answer should be 0.004. If the answer is same, then the option A is correct. So just do the cross multiplication. So when you do the cross multiplication, you will get 0.02 into 1 divided by the other number, that is 5. So the correct answer for this, if you solve this, you will get 0.004 moles. So it is the same answer. So option A is correct. So the statement A is correct. Now let us see the statement B. Again 200 ml of Ki. 200 ml of Ki will be having 0.02 moles. 200 ml of Ki solution reacts with 0.06 mole of H2SO4. So H2SO4 in ionic equation, it is represented as H plus. So let us see that. So according to this equation, 5 moles of I minus reacts with 6 moles of H plus. So 5 moles of I minus reacts with 6 moles of H plus. Therefore, 0.02 moles of I minus reacts with how many moles of H plus? So again do the cross multiplication. So when you do the cross multiplication, you will get 6 into 0.02 divided by 5. So when you solve this, you will get 0.024 moles. So but in question it is given 0.06 moles, but actually we will get 0.024 moles. So option B is wrong. So let us see option C. 0.5 liters of Ki is mentioned. So let us write that 0.5 liters of Ki. So again volume is mentioned. Find the number of moles. Number of moles equal to molarity into volume. So that is equal to 0.1 into 0.5. So that is equal to 0.05 moles. Now see the question. 0.5 liters of Ki solution produced 0.005 moles of I2. So we are going to compare iodide ion with the product I2. So see the stoichiometric coefficient. 5 moles of iodide ion reacts to give 3 moles of I2. So let us write that 5 moles of I minus gives 3 moles of I2. So here we are having what? 0.05 moles of I minus gives how many moles of I2? So same method. So you will get 3 into 0.05 divided by 5. So you will get 3 into 0.01. So that is obviously equal to 0.03 moles of I2. So let us see the option. Here it is mentioned 0.05. So the statement C is wrong. Now the last statement, equivalent weight of KO3 is equal to molecular weight by 5. So see that IO3 minus. So that is only what? KIO3. This IO3 minus is converted to iodine. So let us write the half reaction. IO3 minus is converted to I2. So you find the oxidation number for iodine. So IO3 minus for iodine, let us keep it as X. X minus 2 into 3 is equal to minus 1 because the charge is minus 1. So X minus 6 equal to minus 1. X is equal to plus 5. So the oxidation state of iodine here is plus 5 and in the elemental form it is 0. So from plus 5 it has decreased to 0. So obviously it is reduction. So what is reduction? Reduction is gain of electron. So how many electrons are gained? So how many electrons are gained? That is the change in oxidation number, that is 5 electrons. 5 electrons are gained by one iodine atom. Here no need to balance this equation because we are going to find only the n factor. So the n factor, that is the valency factor, so it represents the change in oxidation number from +5, the oxidation number changed to 0, the change in oxidation number per mole of the substance. So for one iodine atom, what is the change in oxidation number? So from +5 to 0, the change is 5. So here the n factor is also 5. No need to balance this equation. For one iodine atom only, we are finding the n factor. Now let us see the formula of equivalent weight. Equivalent weight is equal to molecular weight divided by n factor. So molecular weight divided by n factor for KiO3, that is IO3 minus, is 5. So it is molecular weight by 5. So option D is correct. So the correct options are A and D. So choose the correct answer from the given options. The correct option is option 1, A and D. The next question is, some CO2 gas was kept in a sealed container at a pressure of 1 atmosphere and at 273 Kelvin. So 1 atmosphere and 273 Kelvin is standard temperature and pressure. So keep this in mind. This entire amount of CO2 gas was later passed through an aqueous solution of CaOH twice. So this carbon dioxide gas is passed into CaOH twice, that is lime water. So after this reaction, the excess unreacted CaOH twice was later neutralized with 0.1 m of 40 ml HCl. So first what is happening? CO2 is passed to CaOH twice. Then here we are having some excess unreacted lime water, CaOH twice. This was later neutralized. So neutralization reaction takes place. So this was neutralized by HCl. So here the concentration of HCl is given 0.1 m of volume is 40 ml. So with this we can find the number of moles. Number of moles equal to molarity into volume. So that is equal to 0.1 into volume is 40 ml, that is 0.4 liters. So you will get 0.04 moles. So 0.04 moles of HCl was used in this reaction. Now let us see the remaining question. If the volume of the sealed container of CO2 was X, then X is dash centimeter cube. So at first we saw that CO2 was kept in a sealed container. So the volume is represented by X. So what is the value of X? So here an additional information is given. The entire amount of CO2 reacted with exactly half the initial amount of CaOH twice. So the entire amount of CO2 reacted only with what? Half of the initial amount of CaOH twice. So for example, if CaOH twice initially it is having the concentration, initial amount is 2x, means here only x, that is half of the initial amount is used for the reaction of CO2. So what is the remaining? That is excess. Here we are seeing the excess, no? So what is the remaining? 2x minus x. So x is the remaining. So here we can note down one thing, that is the amount of CaOH twice reacted is equal to excess of CaOH twice, because the amount of reacted is also x. Excess of CaOH twice is also x. So both are same. So keep that in mind. Now let us find the volume of CO2. So first let us see the neutralization reaction of HCl and CaOH twice. So CaOH twice is a base that is going to react with HCl. So it is a neutralization reaction in which a salt is formed, CaCl2, and water is formed, H2O. So here you have to balance the equation. 2 chlorine atoms are there in the product side and 2 hydrogen atoms are there in product side. So just write 2 HCl. So from this balanced equation, 1 mole of CaOH twice reacts with how many moles of HCl? 2 moles. 2 moles of HCl. Therefore, how many moles of CaOH twice reacts with, here we found the number of moles of HCl as 0.04 moles. So, how many moles of CaOH twice reacts with 0.04 moles of HCl? So, when you see the cross multiplication, so the relation is simple only, half. So, for 2 moles of HCl, 1 mole of CaOH twice. And for 0.04 moles of HCl, 0.02 moles of CaOH twice will be used. So, we can see the cross multiplication also, 0.04 into 1 divided by the other number 2. So, which is obviously 0.02 moles. So, this is the CaOH twice number of moles reacted with HCl. So, this is actually the excess amount, excess of CaOH twice, because the excess only reacted with the HCl. Here we already wrote that amount of CaOH twice reacted is equal to excess of CaOH twice. So, we found the excess of CaOH twice as 0.02 moles. Then the amount of CaOH twice is also 0.02 moles. Now, the number of moles of CaOH twice reacted will be equal to number of moles of CO2 in the container, because in question it is mentioned the entire amount of CO2 reacted with the CaOH twice. So, we saw the reacted CaOH twice as 0.02 moles. So, the amount of CO2 is also 0.02 moles. Now, you have to find the volume of CO2. So, we know the formula, number of moles is equal to the given volume divided by the molar volume. So, the given volume is the volume mentioned in question, but here we have to find this given volume only. So, we know the number of moles, and the molar volume also we know that, because already it is mentioned, it is STP condition. So, in STP condition, the volume occupied by 1 mole of a gas is 22.4 liters, or you can write 22,400 milliliters, because here the volume is mentioned is in cubic centimeter. So, it is 22.400 cubic centimeter. So, how to find the volume? You have to multiply the number of moles into molar volume. So, volume of CO2 is equal to number of moles into molar volume. So, number of moles we found as 0.02 into molar volume is 22.400 cubic centimeter. So, this is equal to, so here you will get the answer as 44.8 centimeter cube. So, the answer is 44.8. You have to round off to the nearest integer. So, it is 45. So, the answer is x value is 45 centimeter cube. Now, let us see the topic wise question discussion for the remaining previous year questions. The next question from the year 2024, match list 1 with list 2. So, in list 1 we are having the reaction, in list 2 the type of redox reaction. Already we saw this type of question. So, let us see the first option A, N2 plus O2 gives 2NO. So, clearly two substances combine to form a product, single product. It is clear. So, it is a combination reaction. So, the first equation is a combination reaction. So, for A, the correct match is 4. For A, the correct match is 4 combination. Then going to the next option B, 2 PbNO3 twice gives 2 PbO plus 4 NO2 plus O2. So, in reactant side only one compound is there, but in product 3 compounds are there. So, a single substance decomposes into 2 or more substances is called as decomposition reaction. So, the next reaction, next option B option is decomposition. So, decomposition is option 1. Next is option C. C option, 2Na plus 2H2O gives 2NaOH plus H2. So, in this reaction, sodium displaces hydrogen from water molecule and H2 gas is evolved. So, this is a displacement reaction. So this is a displacement reaction. So for option C, the correct match is 3. Then going to the last option. So the last option is option D. NO2, 2NO2 plus 2OH minus gives NO2 minus plus NO3 minus plus H2O. So first let us see the oxidation state of nitrogen in reactant and in both the products NO2 minus and NO3 minus, because nitrogen is present in two different compounds in the product side. So how will you find the oxidation state? For the unknown element it is X, and the oxidation state of oxygen is -2 and 2 atoms are there and everything is equal to 0. So X minus 4 equal to 0, the value of X is +4. So here the oxidation state of nitrogen is +4. Then X minus 2 into 2, here the charge is -1. So X minus 4 equal to -1, X is equal to +3. So here the oxidation state is +3. Then NO3 minus, for unknown element it is X. X minus 2 into 3 is equal to -1. So X minus 6 equal to -1, X is equal to +5. So here the oxidation state is +5. Now if you compare the oxidation state of the reactant and the products, from +4 to +3 is decrease in oxidation state, so it is reduction. Then from +4 to +5 is increase in oxidation state, so it is oxidation. So a same element nitrogen undergoes both reduction and oxidation. So this is an example of this proportionation reaction. So for option D, the correct match is 3. So let us write all the options together. For A, 4. For B, 1. For C, it is 3. And for D, it is 3. So if you see the options, clearly you can find the answer. Only option D, in only option D, A is having the match 4. So with the first reaction itself, you can find the answer. So in only option D, for the match A, 4 is given. So the B1, C2, D3 and all is correct. So option D is the correct answer. Next question is, 1 mole of PBS is oxidized by X moles of O3 to get Y moles of O2. X plus Y is. So here oxidation of PBS, that is lead sulfide, takes place. So let us write the oxidation half reaction. Lead sulfide is oxidized, that is addition of oxygen takes place and it is converted to lead sulfate. So lead sulfide is converted to lead sulfate. So we know oxidation is loss of electron. So how many electrons are lost? We are going to see that. So in the reactant side and product side, oxidation state of lead is same. Oxidation state of lead is +2 in both the reactant and the product, because sulfide is S2 minus. Sulfate is also SO4 2 minus. So the anion is having the charge 2 minus. So the cation, the metal, will have the charge +2. So let us see the oxidation state of sulfur. So lead sulfide is having the oxidation state of -2. And if you calculate the oxidation state of sulfur in PbSO4, as I said, lead is having the charge 2 +2 plus the unknown element X plus oxygen is having the charge -2 into 4 atoms, everything equal to 0. So 2 plus X minus 8 equal to 0. So X minus 6 equal to 0. So the value of X is +6. So from -2 to +6 is increase in oxidation state. So obviously it is oxidation. So what is the difference? The difference is 8 electrons. So 8 electrons are lost in this oxidation. Other than that, you have to balance the oxygen and the hydrogen atoms. First, let us see the oxygen atoms. 4 oxygen atoms are present in product side. So you have to write 4 H2O in the reactant side. Now if you see the hydrogen atoms, 4 into 2, 8 hydrogen atoms are present in the reactant side. So to balance that, you have to write 8H plus in the product side. So this is the oxidation half reaction. Now let us see the reduction half reaction. So in reduction half reaction, already in question itself it is mentioned, ozone is converted to O2. So O3 is converted to O2. So we cannot find how many electrons are gained in this reaction, because we know reduction is gain of electron, but the oxidation state of ozone, oxygen in ozone is also 0, and for oxygen in dioxygen molecule also the oxidation state is 0. So we cannot find directly. So first let us balance this equation. 3 oxygen atoms are there in the left hand side. Only 2 oxygen atoms are present in the right hand side. So let us write one water molecule. So in one water molecule, one oxygen atom is there. So the number of oxygen atoms are balanced. Now, if you see the hydrogen atoms, in right hand side, 2 hydrogen atoms are there. So in the reactant side, you have to write 2H plus. Now, see the charge on the reactant side and the product side. In reactant side, how many charges are there? 2 into plus. So 2 positive charges are there in the reactant side. In product side, there is no positive charge or there is no negative charge also. So the charge is 0, neutral. So the left hand side also should be neutral. For that, we are going to balance this positive charge by adding the negative charge, that is the electron. So for 2 positive charge, 2 electrons are added. So this is the reduction half reaction of the conversion of O3 into O2. So oxidation half reaction and reduction half reactions are written. Now you have to equate the number of electrons. The number of electrons in the oxidation half reaction is 8, but in the reduction half reaction it is only 2. So you have to multiply this overall equation by 4. So now the half reaction, reduction half reaction is 4O3 plus 4H, sorry, 8H plus 8 electrons gives 4O2 plus 4H2O. So now we are going to add the first equation and the second equation. In first equation, 4H2O is there in the reactant side. In second equation, 4H2O is in the product side. So we can cancel that. Then in the first equation, 8 electrons and 8H plus is there in the product side. In second equation, 8 electrons and 8H plus is in the reactant side. So we can cancel that. So we are going to write the remaining. PBS plus 4O3 gives PbSO4 plus 4O2. So here in question it is mentioned X moles of O3 and Y moles of O2. So how many moles of O3 is there? Value of X is 4. How many moles of O2 is there? Value of Y is also 4. So what is X plus Y? So X plus Y is equal to 4 plus 4, that is equal to 8. So the answer for this question is 8. Next question is, which of the following cannot function as an oxidizing agent? So what is an oxidizing agent? An oxidizing agent oxidize other substance and itself it will undergo reduction. An oxidizing agent should undergo reduction. What is reduction? Reduction is gain of electrons. So when a substance has the ability to gain electrons, it means it can act as an oxidizing agent, because oxidizing agent should undergo reduction. So let us see the options. In first option, N3 minus is given. So monoatomic ion. So the oxidation state of nitrogen is the charge. So the oxidation state is -3. So here what is this -3 represents? Already nitrogen has 3 more electrons. So only the oxidation state is -3. So the least oxidation state nitrogen can exhibit is -3 only. Already nitrogen is present in its minimum oxidation state only. Still it cannot undergo reduction. Why it cannot undergo reduction? So you see the atomic number of nitrogen. Nitrogen having the atomic number 7 is having the electronic configuration 2, 5. So the outermost shell is having 5 electrons. So to attain stability, it gains 3 more electrons. So after the gain of 3 more electrons, it will become 2, 8. So only 3 more electrons it can accommodate. Already it is having 3 more electrons. So only the charge is N3 minus. So already nitrogen is present in its least oxidation state, minimum oxidation state. Already it is present. So further it cannot undergo reduction. What is reduction? Gain of electron. So further it cannot gain electrons. So if it cannot gain electrons, it cannot undergo reduction and it cannot act as a oxidizing agent. So option A is the correct answer. Let us see the other options also. SO4 minus 2 minus. So let us find the oxidation state of sulfur. X minus 2 into 4 equal to minus 2. X minus 8 equal to minus 2. X equal to plus 6. So the oxidation state of sulfur is plus 6. So sulfur can undergo reduction because sulfur can exhibit a lower oxidation state up to minus 2, from minus 2 to plus 6. So in between it is having plus 4 oxidation state also. So from minus 2 to plus 6 it can exhibit the oxidation state. So sulfur can undergo reduction. Then going to the next option, X minus 2 into 3 is minus 6 equal to minus 1. So X is equal to plus 5. So here bromine is present in the positive oxidation state. So whenever an element is present in the positive oxidation state, it means it is having less electrons. As the electron is less, the oxidation state is positive. So it means it can gain electron. So it will undergo reduction. So for bromine also positive oxidation state is there. Bromine can exhibit a lower oxidation state up to minus 1. So bromine also can undergo reduction. Then going to the next one, manganese in MnO4 minus. X minus 2 into minus 4 is minus 8 equal to minus 1. X equal to plus 7. So here also manganese is present in the positive oxidation state. Highest oxidation state plus 7. We all know manganese undergo reduction in acidic medium by gaining 5 electrons. It will be converted to Mn2 plus. Then in basic medium, it will gain 3 electrons and it is converted to MnO2. So manganese definitely undergo reduction. So the correct option is option A. Next question is, the compound that cannot act both as oxidizing and reducing agent is. So we are talking about a compound that should act as both oxidizing and reducing agent. Oxidizing agent should undergo reduction. So we saw reduction as gain of electrons. Here we can define reduction as decrease in oxidation state. Then reducing agent should undergo oxidation. So what is oxidation? Increase in oxidation state. So let us see the options. In first option, H3PO4 as it is given. Here the oxidation state of phosphorus is plus 5. So first let us check that. I will show that for you. Hydrogen is having the charge plus 1 and the 3 atoms are there. So plus 1 into 3 plus unknown element X plus oxidation state of oxygen is minus 2 into 4, everything equal to 0. So 3 plus X minus 8 equal to 0, X minus 5 equal to 0, X is equal to plus 5. So for phosphorus, the oxidation state is plus 5. Now let us see the oxidation state of nitrogen in the next compound. So 1 plus X minus 2 into 2 atoms are there. So 4 equal to 0. X minus 3 equal to 0. So X is equal to plus 3. So the oxidation state of nitrogen is plus 3. Then we will see the oxidation state of sulfur. So 1 into 2 plus X plus minus 2 into 3, everything equal to 0. So 2 plus X minus 6 equal to 0, X minus 4 equal to 0. So the oxidation state of sulfur is plus 4. Then in hydrogen peroxide, what is the oxidation state of oxygen? So for hydrogen it is 1 into 2 plus 2X, everything equal to 0. So 2 plus 2X equal to 0, 2X equal to minus 2. So X is equal to minus 1. So the oxidation state of oxygen is minus 1. Now let us see the oxidation state of the individual elements. For phosphorus, the maximum oxidation state is plus 5 only. So that plus 5 is already exhibited by phosphorus in this compound. So further, there is no increase in oxidation state for phosphorus because phosphorus has a maximum oxidation state of plus 5 only. Already that plus 5 is shown by phosphorus in this compound. So further there is no increase in oxidation state. Further it cannot lose its electrons. So further there is no oxidation. So further there is no oxidation for phosphorus in this compound. So if there is no oxidation, then it cannot act as a reducing agent. So in this compound, phosphorus cannot act as reducing agent, but it can act as a oxidizing agent because it can undergo reduction. It can gain electrons, but it cannot lose electrons because the maximum oxidation state, that is, the maximum number of electrons are already lost by phosphorus. So the correct option is option A. Now let us see the other options also. In option B, nitrogen is having the oxidation state of +3. So further it can increase or it can go up to +5 for nitrogen, or it can also go down to -3. In the previous question itself we saw nitrogen can also increase its oxidation state to +5, or it can also decrease to -3. So it can act as both oxidizing and reducing agent. Then next to sulfur in option C. So for sulfur the oxidation state is +4. So it can go up to +6. So it can increase its oxidation state and it can undergo oxidation, or it can go down to -2. So sulfur can also decrease its oxidation state to -2. So it undergoes both oxidation and reduction. So it acts as both oxidizing and reducing agent. Then in option D, oxygen is having the intermediate oxidation state -1. So it can go up to 0. In elemental state, oxygen is having the oxidation state 0, or it can go down to -2. So oxygen can undergo both oxidation as well as reduction. So the only option A, in that only the compound cannot undergo oxidation as it is already exhibiting the maximum oxidation state +5. So the correct option is option A. The next question is, the redox reaction among the following is formation of ozone from atmospheric oxygen in the presence of sunlight. From atmospheric oxygen, ozone is formed. So to balance this equation, 3O2 gives 2O3. Is this a redox reaction? No, it is not a redox reaction because the oxidation state of oxygen in atmospheric oxygen is 0, as well as in ozone also it is 0. There is no change in oxidation state. So it is not a redox reaction. Next option, reaction of COH2O6 Cl3 with AgNO3. This reaction is also not a redox reaction. I will explain that. This reaction is actually a precipitation reaction. So if you see the equation, CO H2O 6 times Cl3 plus AgNO3, it is actually a double displacement reaction. The nitrate ions are displacing and it is combining with this complex. So you will get CO H2O 6 times NO3 thrice plus silver and chlorine. They both combine to form silver chloride, AgCl. So here to balance this equation, you have to write 3 AgNO3. So here also you will get 3 AgCl. So the silver chloride is precipitated. Here there is no change in the oxidation state of any element. Silver is having the oxidation state of +1 in the reactant side, and in product side also it is +1. Same chlorine is having the oxidation state of -1. In product also it is having -1. Nitrogen also, it is present in +5 oxidation state in this nitrate ions. So it is actually NO3 minus X minus 2 into 3 is equal to -1. X minus 6 equal to -1. X is equal to +5. So in product side also it is present as nitrate ions only. So it is present in +5 oxidation state. So the oxidation state does not change for any element. So it is not a redox reaction. Going to the third option, reaction of H2SO4 plus NaOH. So H2SO4 is a acid. NaOH is a base. Acid and base react, and that reaction is called as neutralization reaction. Neutralization reaction is not a redox reaction. So this is also not a redox reaction. Here you will get salt and water. So the salt you will get here Na2SO4 plus H2O. So to balance this reaction, you have to write 2H2O in the reactant side. So this reaction is also not a redox reaction. The last option is combination of dinitrogen N2 plus dioxygen O2 to give 2NO. So this is a redox reaction because nitrogen in its elemental form will have the oxidation state of 0, as well as oxygen will also in its elemental form will have the oxidation state 0. Then going to the product side, oxygen will have the oxidation state of -2 and nitrogen will have the oxidation state of +2. So for nitrogen it is increase in oxidation state, so it is oxidation, and for oxygen it is decrease in oxidation state, so it is reduction. So it is a redox reaction. So the correct option is option D. Next question is, which of the following reactions is an example of redox reaction? First equation, XeF4 plus O2F2 gives XeF6 plus O2. First you have to find the oxidation states of the elements. So we know that the oxidation state of fluorine is always -1. It will not at all change. So obviously you have to see the other elements. So here for xenon, 4 fluorine atoms are there. So -1 into 4 will give -4. So x -4 equal to 0. X is equal to +4. So like that you have to calculate. It is very simple. So straight away I will write the oxidation states. So for xenon it is +4 in the reactant side. Then going to oxygen. So 2x plus -2 equal to 0. 2x is equal to 2. X is equal to +1. So the oxidation state of oxygen is +1. Then going to the product, XeF6. So 6 fluorine atoms are there. So for xenon, x minus 6 equal to 0. So the value of x is +6. Oxygen in its elemental form will have the oxidation state of 0. So for oxygen, from +1, it is reduced to 0. So it is decrease in oxidation state. So it is reduction. Then for xenon, from +4 to +6, it is increase. Increase in oxidation state is oxidation. So obviously it is a redox reaction. So it is an example of redox reaction. So the correct answer is option A. Let us see the other options also. XeF2 plus PF5 gives XeF plus PF6 minus. So here the oxidation state of xenon will be +2. Then for phosphorus, 5 fluorine atoms are there. So 5 negative charges. So for phosphorus it is +5. Then going to the product. So you have to see the two complex ions, two ions separately. So let us find the oxidation state of xenon. X -1 equal to +1. The charge is +1. So x is equal to +2. So here the oxidation state of xenon is again +2. In reactant side also it is +2, product side also +2. Then for phosphorus, x -6 equal to -1. X is equal to +5 when -6 goes to the right hand side. So here also the oxidation state of phosphorus is again +5. So there is no change in the oxidation states. So it is not a redox reaction. Then going to the next option, XeF6 plus H2O gives XeOF4 plus 2HF. So XeF6 xenon oxidation state is +6. H2O oxidation state of oxygen is -2. Then going to this compound XeOF4, let us find the oxidation state of xenon X, and the oxidation state of oxygen will be -2. Then for fluorine it is -1 into 4 atoms equal to 0. So x -2 -4 equal to 0. So the oxidation state of xenon is again +6. So there is no change in the oxidation state. Then for oxygen also I have mentioned it is -2. So there is no change in oxidation states. So the third reaction is also not a redox reaction. Going to the fourth reaction, XeF6 plus 2H2O gives XeO2F2 plus 4HF. So the oxidation state of xenon is again +6. For oxygen it is -2. Then here in this compound the oxidation state of oxygen is -2. So you have to find the oxidation state of xenon. So X -2 into 2 atoms. Then for fluorine also it is -1 into 2 equal to 0. So X -4 -2 equal to 0. So the oxidation state of xenon is +6. Again the same oxidation states. So there is no change in oxidation state in the options B, C, D. So the correct option is option A. It is only example of a redox reaction. The next question is, copper becomes green when exposed to moist air for a long period. This is due to, so this green coating on copper when it is exposed to moist air is due to the reaction that follows. Copper, when it reacts with moist air, it consists of water molecule and the carbon dioxide and oxygen molecule. So all these react to form copper hydroxide and copper carbonate. So this copper hydroxide is a base. So together it is called basic carbonate. So a base and a carbonate is formed. So a basic carbonate gives the green color. So the correct option is the formation of a layer of basic carbonate. So the base is copper hydroxide and carbonate is copper carbonate of copper on the surface of copper. So option B is the correct answer. The next question is, which of the following chemical reactions depict the oxidizing behavior of H2SO4? Oxidizing behavior of H2SO4. So to act as an oxidizing agent, the reagent should itself undergo reduction. And what is reduction? Reduction is decrease in oxidation state. So in H2SO4, you have to see sulfur. So when you calculate the oxidation state, for hydrogen it is +1. +1 into 2 atoms plus X plus for oxygen it is -2 into 4 equal to 0. So 2 plus X minus 8 equal to 0. X minus 6 equal to 0. So the value of X is +6. So the oxidation state of sulfur is +6 in this H2SO4. So you have to see in which reaction there is a decrease in oxidation state from +6 for sulfur in the product side. So let us see the reactions. So the first reaction, NaCl plus H2SO4 gives NaHSO4 plus HCl. Now let us calculate the oxidation state of sulfur in product side for this option A, NaHSO4. So for sodium, it is a group 1 element. So the oxidation state is always +1. Plus for hydrogen also it is +1. Plus for sulfur it is X. Plus for oxygen it is -2 into 4 equal to 0. So again 2 plus X minus 8 equal to 0. So again you are getting the same number +6. So in reactant also the oxidation state of sulfur is +6. In product also it is +6. So it is not a redox reaction itself. So it is actually a neutralization reaction. A salt is formed from an acid. So it is a neutralization reaction. So the option A is wrong. So let us go to the next option. So the next option, the oxidation state of sulfur in the reactant side is +6. Let us see in the product side. So in next option, SO2Cl2. So X -2 into 2 plus -1. For chlorine, the oxidation state is -1 into 2 equal to 0. So X minus 4 minus 2 equal to 0. So the value of X is again +6. So it is also not a redox reaction. Then going to the next option, the oxidation state of sulfur in the reactant side is +6. And let us see the oxidation state of sulfur in the product side. So in next option, SO2. So X -2 into 2 equal to 0. X minus 4 equal to 0. So the value of X is +4. So here there is a decrease in oxidation state. So decrease in oxidation state means it is a oxidizing agent. So in option C, H2SO4 acts as an oxidizing agent. Let us see the last option also. So in last option, it is a CaOH twice. A base is reacting with H2SO4 acid. So the product is CaSO4, a salt, and H2O, water is formed. So it is obviously a neutralization reaction. So it is not a redox reaction itself. So the correct option is option C. In option C only, sulfur acts as an oxidizing agent. Now let us go to the next topic, oxidation number. The next question is, from the given list, the number of compounds with +4 oxidation state of sulfur is. So let us see the given compounds. So the first compound is SO3. Oxidation state of sulfur is unknown. So X -2 into 3 equal to 0. So the value of X is +6. Now we will go to the second compound, H2SO3. So +1 into 2 plus the unknown element x minus 2 into 3 equal to 0. So 2 plus x minus 6 equal to 0. So the value of x is plus 4. So the oxidation state of sulfur in this compound is plus 4. Let us go to the next compound, SOCl2. X minus 2 minus 1 into 2 equal to 0. X minus 2 minus 2 equal to 0. So the value of x is plus 4. So in this compound also the oxidation state of sulfur is plus 4. Then we will go to the next compound, SF4. Very simple compound. X minus 1 into 4 equal to 0. X minus 4 equal to 0. So the value of x is plus 4. So in this compound also the oxidation state of sulfur is plus 4. Next compound is BaSO4. Barium is a group 2 element. For group 2 element, the oxidation state is plus 2. Then the unknown element X plus oxidation state of oxygen is minus 2 into 4 equal to 0. So 2 plus x minus 8 equal to 0. So x minus 6 equal to 0 and the value of x is plus 6. So the next compound, last compound, H2S2O7. So the oxidation state of hydrogen is 1 into 2 plus 2x plus minus 2 into 7 equal to 0. So 2 plus 2x minus 14 equal to 0. 2x, and when you subtract 2 and minus 14 you will get minus 12. So 2x equal to plus 12. So the value of x is again plus 6. So when you solve this you will get the value of x as plus 6. So only in 3 compounds the oxidation state of sulfur is plus 4. So the answer is 3. The number of compounds with plus 4 oxidation state is 3. Next question is, in chromyl chloride, the oxidation state of chromium is. So the formula of chromyl chloride is CrO2Cl2. So you have to find the oxidation state of chromium. So X minus 2 into 2 minus 1 into 2 equal to 0. X minus 4 minus 2 equal to 0. X minus 6 equal to 0. And the value of X is plus 6. So the oxidation state of chromium is already plus is given. So the answer is 6. The next question is, in ammonium phosphomolybdate, the oxidation state of molybdenum is. The formula of ammonium phosphomolybdate is NH4 tries PO4 dot 12 MoO3. Here, simply you can calculate the oxidation state of molybdenum by taking this unit alone. I will explain that. The charge of this ammonium ion is NH4 plus and 3 units are there. So, plus 1 into 3. Then phosphate ions are having the charge PO4 3 minus. So, here the oxidation state is minus 3. So, the charge is minus 3. So, already plus 3 and minus 3. So, this compound is overall neutral because plus 3 and minus 3 will get cancelled. And this compound is also separately neutral. So, no need to look into this compound. Now, leave this 12 MoO3. So, leave this 12. Let us just take the molybdenum, MoO3, molybdenum trioxide. So, the unknown element molybdenum is having the oxidation state X plus oxidation state of oxygen is minus 2 into 3 atoms. So, this is equal to 0 because this compound is separately neutral and this compound is also separately neutral. Already I told that. So, let us not see the other compound, NH4 tries PO4. So, just calculate the oxidation state here. X minus 6 equal to 0. So, the value of X is plus 6. So, the oxidation state of molybdenum is plus 6. The next question is, on reaction with stronger oxidizing agent like KiO4, potassium periodate, hydrogen peroxide with the evolution of O2. So, they are telling that potassium periodate reacts with hydrogen peroxide and in this reaction there is evolution of O2. So, here potassium periodate acts as a oxidizing agent. So, there is oxidation of this hydrogen peroxide. So, they are telling this reaction and what are they asking? The oxidation number of iodine in KiO4 changes to dash. So, actually in oxidation of hydrogen peroxide there is evolution of O2 and as well as there is the formation of water molecule also. So, if you see count the number of oxygen atoms, O2 and here another one oxygen atom is also there. So 3 oxygen atoms are there in the product side. In this KiO4, 4 oxygen atoms are there and 2 oxygen atoms are there in the hydrogen peroxide. So totally 6 oxygen atoms are there, but already 3 atoms are there in this product side. So the remaining is 3. So that 3 you have to write as KiO3. So there is the formation of potassium iodate. So potassium periodate is converted to potassium iodate. So now let us calculate the oxidation states of iodine in both these compounds. So in KiO4, potassium is a group 1 element. So always it will have the oxidation state of +1, plus the oxidation state of iodine is X, plus -2 into 4 equal to 0. So 1 plus X minus 8 equal to 0. X minus 7 equal to 0. So the value of X is +7. So the oxidation state of iodine in potassium periodate is +7. Now let us go to potassium iodate. So 1 plus X plus -2 into 3 equal to 0. So 1 plus X minus 6 equal to 0. X minus 5 equal to 0. So the value of X is +5. So the oxidation number of iodine in KiO4, that is +7. So the oxidation number of iodine in KiO4 changes to dash. It changes to +5. So the answer is +5. The oxidation states of iron atoms in compounds A, B and C respectively are X, Y and Z. So in A it is X, in B it is Y, and in C the oxidation state is Z. The sum of X, Y and Z is dash. So let us find the oxidation states. In first compound, Na4 Fe Cn 5 times NOS. So Na4, the sodium atom is a group 1 element and it will always have the oxidation state of +1 and 4 atoms are there. So overall the charge is +4. So overall this whole compound is neutral. So when this sodium atoms are having the charge +4, so this part of the complex will have the charge of -4. So this part Fe Cn5 NOS will have the charge of -4. So only the whole compound is a neutral compound. Now let us find the oxidation state of iron. So X, cyanide ion is having the charge of -1. So -1 into 5, and thionitrite ion, thionitrite ligand also is having the charge of -1, and everything equal to the charge -4. So X -5 -1 equal to -4. X minus 6 equal to -4. So the value of X is -4 plus 6. So that is +2. So the oxidation state of iron is +2. So the value of X is +2. The next compound is Na4 FeO4. So again Na4 will have the charge of +4. So the other part will have the charge of -4. So FeO4 -4. So the oxidation state of iron is Y. Y minus oxidation state of oxygen is 2 into 4 atoms, everything equal to -4. So Y minus 8 equal to -4. So the so the Y value is -4 plus 8. So the answer, so the oxidation state of Y is +4. So the value of Y is +4. The next compound is Fe2CO9. So the oxidation state of iron is Z. So 2Z, and the charge of this carbon monoxide ligand is 0. So plus 9 carbon monoxide ligands are there. 9 into 0, everything equal to 0. So 2Z plus 0 equal to 0. So 2Z equal to 0 and the value of Z is also 0. So the value of Z is 0. In this question they are asking the sum of X plus Y plus Z. So X value is 2. 2 plus 4 plus 0, everything equal to 6. So the answer is, so I will erase this. So the answer, final answer is 6. The oxidation states of transition metal atoms in K2Cr2O7, KMnO4 and K2FeO4 respectively are X, Y and Z. The sum of X, Y and Z is. So it is a very easy question. First compound is potassium dichromate. So you have to find the oxidation state of the transition metal. So here the transition metal is chromium. So potassium is a group 1 element. So always +1 oxidation state into 2 plus 2x, because 2 chromium atoms are there, plus minus 2 into 7 equal to 0. So 2 plus 2x minus 14 equal to 0. 2x minus 12 equal to 0. So the answer is x value is plus 6. So the oxidation state of chromium in this potassium dichromate is plus 6. So the x value is plus 6. Then the next compound KMNO4. So here the transition metal is manganese. So again potassium group 1 element plus 1 plus x plus oxygen minus 2 into 4 equal to 0. So 1 plus x minus 8 equal to 0. X minus 7 equal to 0. So the value of x is plus 7. But here you have to change the variable. So here let us keep this as y. So the value of y is plus 7. So the oxidation state of manganese in this potassium permanganate is plus 7. Then going to the next compound K2FeO4. So the oxidation state of iron. So plus 1 into 2 plus Z plus minus 2 into 4 equal to 0. So 2 plus Z minus 8 equal to 0. Z minus 6 equal to 0. So the value of Z is plus 6. So the Z value is plus 6. Now here also they are asking the sum of x plus y plus Z. So x plus y plus Z is x plus y plus Z equal to 6 plus 7 plus 6. So 6 plus 7 is 13. 13 plus 6 is 19. So the sum of x plus y plus Z is 19.